Good day to you coders, and thank you for supporting us on Project Collaborate. In this video, we are going to be discussing sorting. So sorting in programming is a very fundamental topic, and there's actually a lot of things that are intertwined with sorting. So when we talk about sorting, we're mainly talking about sorting arrays in numerical order. And so we have this integer array right here, and it has all these numbers. If you notice, it's not all in numerical order actually right now. And so what we're going to do is we're going to call a method from the arrays class called sort. And so if you notice in our imports, I imported java.util.asterisk, and this is necessary in order to access the arrays class because the arrays class is part of Java utilities. And so in order to sort this array, what we're going to do is we're going to do arrays.sort, and then your parameter will be your array name that you want to sort. And so if we just run that, so you'll notice our array is 1, 2, 4, 9, 6, etc., etc. It's not in order, which is the point. Well, here, after having printed out our array, you'll notice that it's actually in numerical order. And so ArrayLists can also do something very similar. However, it uses a class called the collections class. And so with ArrayList, linked list, etc., in order to sort those, you need to do collections.sort, and then you can do ArrayList. And then if you print this out, and so if we print it out as well before, then if we run this, you'll notice that our original array list was 99, 88, 77, 66, but after using collections.sort, we're able to reverse it, well, not reverse it, but sort it in numerical order, so it's 66, 77, 88, and then 99. And then there's two sorting algorithms I would like to talk about. The first is called bubble sort. So with bubble sort, I've made a method here. It's going to take in an integer array, and then at the end it'll return that array again, but sorted. So to start, essentially how bubble sort works is it'll compare adjacent elements, and if the element before the next element is greater, then it'll switch those two. So I think it'll just be easier if we explain in code. So what we have right here, we'll start with a Boolean value called sorted. And so with this implementation, there's actually several implementations of bubble sort, but this is, I think, the easiest one to understand. So we'll set this equal to false because our array has not been sorted yet. And then we'll have a temporary integer. This will just be to hold a value when we're swapping elements. And then we're going to have a while loop. So while our array is not sorted, we're going to set sorted equal to true. And then we're going to go through our array essentially. So we're going to use a for loop to essentially go through each of the elements of our array and compare them to one another. And so int I equals 0, I is less than array dot length, and then I plus plus. And then so if a of I, so if our element that comes first is greater than the element that comes afterward, so if the ith index is greater than the ith plus 1 index element, what we want to do is we want to swap them. So in Java, how we swap is we use a temporary variable. So you set temp equal to a of I, and then you set a of I equal to a of I plus 1, and then a of I plus 1 is equal to temp. And then after we do that, we'll set sorted equal to false. And then, so while we did set sorted equal to true right here, we're setting it equal to false here because essentially how this works is it'll go through here, it'll set this equal to true, but then it'll run the for loop as many times as it needs, and sorted will always be false. And then once it exits the for loop, sorted will be true, therefore it'll exit the while loop. And so we have all of this, and actually I just realized these all have to be an array. So yeah. And then at the end, after we have sorted, we want to return array. And so here we're going to, let's make another integer array. I'm going to comment these out so we don't have them printed. So let's just call this sorted array equals bubble sort. And then we're going to sort this array right here. Array. And then let's print out the sorted array. Oh, there seems to be, there we go. So what's happening here is we're getting an index out of bounds exception. And so actually the error appears to be with this array length. It's actually supposed to be array length -1. And the reason for that is because while you would usually do array.length is less than array.length, when you do I plus 1 right here, that will cause an index out of bounds, because while you are 1 minus the array length, when you add plus 1 right here, you are the array length, and we know that's an index out of bounds. So you want to do -1 right there. And so if we run it now, you'll notice that the array we had here has been sorted like this. Alright, and then the second sort I wanted to go over was the insertion sort. So basically what the insertion sort does is, let's say we have these 4 numbers sorted, right? And then suddenly you see a 6. Oh no, what do you do? So what the insertion sort will do is it'll shift the 6 backwards. So it'll compare it with the 9. Oh, it's less than 9. Move it backwards. Is it less than 4? No, and then so it'll stay there. And then it'll do this with the rest of the numbers as well until everything is completely sorted. So to start, let's actually make this an integer array, and then we'll take an integer array as our input. And so for the implementation for this, we're going to start off with a for loop. Int I equals 0. Oh, I is less than array dot length. And then I plus plus. So we're going to iterate through the whole array. And then we're going to declare an element called called current, and that's going to be the current number that we are analyzing. So array and then we're going to have another integer called j, and we're going to say that is I minus 1. And then what we want to essentially analyze is while j is greater than or equal to 0. So since j is going to be actually used in an array, this has to be greater than or equal to 0 else, because if it's a negative number, it'll be an index out of bounds. And if the current one we're analyzing is less than the one before it, so let's say we are analyzing 6, and if it's less than 9, we will set 6 equal to 9, essentially. So array j plus 1, oh my god, equals array j, right? And then we will subtract j, because the next thing we'd be analyzing is the index of 6, which has been switched with 9, and we would be comparing that with 4. So we would want to subtract j, and it'll do this until 6 is at its proper position. And so let's see, there's a lot of brackets here. What does this one mean? Okay, cool, perfect. So after that, we will set array j plus 1 equal to current. And then we will, let's see, we will return array. So if we save that, and then, so with our sorted array, we can do int sorted array 2 equals, that was an insertion sort. Let's actually just call this out. Yes, I forgot my semicolons. And so if you notice here, our insertion sort completed, and it's all been sorted. And so you're probably wondering, why are there so many sorting algorithms? So the thing with all these sorting algorithms is there are algorithms that are faster or slower than others. And so basically there's a thing called end time complexity, and so you can essentially quantify these into an end time complexity, which tells you how long it'll take to go through the sorting algorithm. And so these are just different ways to sort. Some of them have been developed, and like so maybe the slower ones were first developed, and then the faster ones are developed later. So that's about all we have for this video. If you guys have any questions, drop them down in the comments below, and thank you so much for watching.